All right, let's take it home with number 6. A car airbag requires 70 liters of nitrogen gas to inflate properly. So what that's telling us here is that when we inflate an airbag, it needs to be 70 liters. 70 liters is what we're trying to accomplish here. The following equation represents the production of nitrogen gas. And this actually is the equation that's used in like your everyday steering wheel to inflate this, the airbag if the need arises. Part A reads, the density of nitrogen gas is typically 1.16 grams per liter at room temperature. Calculate the number of grams of nitrogen that are needed to inflate the bag. So what's happening here is we're trying to inflate the bag. What are we trying to inflate it to? 70 liters. So this is actually our given. We're being given 70 liters of nitrogen, right? 70 liters of nitrogen gas. And that's a diatomic molecule because it's a nitrogen. So we are trying to get 70 liters of nitrogen. And just FYI, that's 2 significant figures. Even though this is 3 significant figures, this is smaller, so this trumps it. So without knowing what's going on, I'll just tell you right now, I know I have to put liters of nitrogen down here on the denominator because it's the only way I can cancel out that initial unit. Good thing I have a conversion factor in the form of this density that allows me to say for every 1 liter, I have 1.16 grams of nitrogen. Thank you, density. And now I'm set up to calculate the number of grams of N2 that are needed to inflate the bag. So, as complicated as this problem looked to start, all I'm really plugging into the calculator is 70 multiplied by 1.16. Now the calculator gives me 3 significant figures. I'm only supposed to report it in terms of 2, so I'm just going to stick with 81 grams of N2. B, calculate the number of moles of N2 that are needed. Well, we just calculated the number of grams, so this is how many grams are needed. This is the mass needed. If I simply convert these grams into this mass into number of moles, that'll be the correct answer. So again, I'm going to be taking 2 significant figures. Okay, so I need, in terms of sig figs, I need 2. So I'm going to start with this 81 grams of N2. I know for sure I'm going to need to cancel out of that, boom, boom, so that unit immediately goes on the denominator. I'm going to go into moles of N2. Well, that looks like a molar mass. And we know from the periodic table that 1 mole of N2 has a mass of 28.02. Now, just to double check, once I calculate, these grams cancel. I'll be in terms of moles of N2. Just making sure we're doing what we're supposed to do according to the question. Number of moles of N2. Moles of N2. Okay, we're looking good. Let's get the calculator back in here. 81 times 1 divided by 28.02. We end up with a whole bunch of numbers, but I'm only supposed to report 2 significant figures, and so that 100th spot tells me to round up that 10th spot, so I'll go 2.9. 2.9 moles of N2. Now, C, calculate the number of grams of sodium nitride that must be used to generate the that amount of N2 necessary to properly inflate the airbag. So we're still going to this 70 liters, which is 81 grams of nitrogen. The amount is 2.9 moles of nitrogen, right? So we're trying to generate that amount, which is that. But how many grams of this first stuff do we need to put actually inside the steering wheel? So we're going to start with the 2.9 moles of N2. And we're going to go from this number of moles into the mass of something else. So we're going to use 2 conversion factors. I'm going to convert out of moles of N2 into moles of Na in 3, and then out of moles of Na in 3 into grams of Na in 3. That will give me the units of grams of Na in 3 as my final answer. Let's double check that that is working out the way I want it to. Moles of N2 will cancel. Moles of Na in 3 will cancel. There's my only unit left. Well, what's my mole ratio? All the way back up here. Number in front of N2 is 3. Number in front of Na in 3 is 2. But now I need the molar mass of Na in 3. Well, nitrogen has a mass of 14.01. Multiply that by 3. Okay, I got 3 nitrogens plus plus a sodium, which is 22.99. Again, if you don't believe me, check your periodic table. Just trying to save you some time right now. So for every 1 mole, I have 65.02 grams of Na in 3. And now I'm ready to calculate my answer. 2.9 multiplied by 2 multiplied by 65.02 divide by 3 divide by 1. All right, let's see here. Let's see, I need 2 significant figures, right? Yeah, because I brought this number. I got 2 significant figures there. I got 4 there, but the 2 significant figures trump that. So, oh my gosh. I got to report something in the hundreds with just 2 significant figures. Ooh, that's going to be tricky. So I'm going to have 2 options here. I can actually just round it to that tens spot, right? So I'll have 1, 2 significant figures. So I could report this as 130. That is a legitimate way to report this answer. Or I can put it in scientific notation, which might seem more annoying to you, but for scientists it's actually a lot easier. And we would report this as 1.3 times 10 to the second power grams of Na in 3. Right? Both of these are equally correct. They're the exact same thing, whichever one works for you. Unless, of course, the question asks for one specifically. All right, y'all, that'll do it for this worksheet.